Okay, it's nice to be here today. Firstly, thank you to the event organisers and also to IMCD, our distributor, for inviting me to talk with you today. Also, thanks to the translator. This is my first time in Brazil, and if it wasn't for the translator here, I wouldn't have a clue what was going on. So I only wish you were with me yesterday when I was trying to buy a travel adapter for my laptop. It would have been very useful. So I'm here to talk to you about PAGs and the future in synthetic lubes. So we'll kick off. Firstly, GEO Specialty Chemicals isn't a very well-known company in the lubes market at the moment. We're relatively new into lubes, so there's a quick introduction about who GEO are. We're a US company, founded in 1993. We've got a strong presence in the US, but rather less so in terms of manufacturing locations elsewhere. We're a leading producer of specialty chemicals, so we make around 350 specialty chemicals focused on niche markets into a huge array of different industries. We have annual revenues of 400 million US and 550 employees located in 23 locations. So as I mentioned, we recently re-entered the lubes market when GEO Specialty Chemicals bought a manufacturing site in the UK, down in Hythe on the south coast of the UK. This site, however, even though GEO have been relatively new to PAGs and lubricants, the site in the UK is very well established in terms of producing PAG lubricants. So historically we were a Union Carbide site when we first began in the 60s. So we were making PAG lubricants under the Yukon brand for who are now Dow, and also for Brioxes, we were owned by BSF as well. So although the GeoLube brand name is still relatively not so well known, the site in Hythe and also the products that we made have got a long history, and they were very well known in the industry. So just to talk a little bit more about the site in Hythe in the UK. So obviously we're handling EO and PO, so we're a top tier coma site, and we have all of the safety aspects associated with that. We have ISO standard 14001 and 9001, and we're very keen on investing in our people. So we've got a gold award for investors in people. We have a very low turnover of staff. It's a nice area of the UK to live, so generally speaking, when people come, they kind of hang around for a number of years. And from this site, we sell to 50 countries worldwide, so we're active in all of the areas, and we ship to all of the continents in the world. And for most of those countries, we use our distribution partner, IMCD, who are very kind to invite me to come and talk to you today. We use them in Brazil, so for any questions later on, I'll be with the IMCD guys on the stand just outside this door, so if you want to have a chat to me, that's fine. We also make a lot of lubricants for food grade, so the majority of our products are kosher and halal registered. And we also have a number of products listed on the NSF White Book as well. So today I'm going to talk to you about, give a little introduction about polyalkylene glycols. I know Eduardo has already introduced them today already, but for those of you who weren't there for his presentation, I can go through that again. And then talking about why people use PAGs, so talking about energy efficiency, the high performance and the longer drain intervals, and then also some new areas where PAGs are gaining traction due to new environmental regulations as well. So polyalkylene glycols are in the Group 5 range of lubricants, so that basically includes anything which isn't a mineral oil or a PAO. And the general structure is a copolymer of ethylene oxide and propylene oxide. And by varying the amount of EO and PO in the formulation, you can make it water-soluble or water-insoluble. So it's one of the few lubricants where you can make a water-soluble product, which comes in handy for a lot of the applications that PAGs get used in. We can make homo, random, or block copolymers. So we sell our homopolymers and random polymers under the GeoLube brand into lubricants, but we also make some block copolymers under the Bisomer trade name. Those are used in metalworking fluids for defoamers, as was mentioned before by Itomatch, and also for industrial food processing, again, as defoamers. So these are some of the key features about PAGs. I sell PAGs, so I'm obviously going to say they're great. These are our opinions, and I'm welcome to some other forms of opinions, but generally speaking, they're a very high-performing base stock. In terms of lubricity, they've got excellent lubricity due to the high polarity of the product. They've got an excellent viscosity index as well, and very good load-bearing capacity. In terms of stability, they're very shear stable, and they're also terrifically hydrolytically stable as well. And they've got good thermal oxidative stability. And the good thing about PAGs is the byproducts and the breakdown products are also soluble in the PAG, so you don't get any varnish or sludge created from the product. In terms of compatibility, this is one area which has sometimes caused us some issues. So we've got excellent chemical resistance and excellent metal compatibility. Compatibility with seals sometimes need to be checked, but generally speaking, it's very good. But the one area where people have always had an issue is switching between mineral oils, PAOs, and PAGs. Traditionally, PAGs aren't compatible with mineral oils and PAOs. So in terms of switching between the two, that's not generally possible. But if you are interested in oil-soluble PAGs, we're doing a development project at the moment. So we've got some products to offer in terms of oil-soluble PAGs, which can be used as replacements for mineral oils or also as additives in mineral oils to boost the performance. In terms of temperature, PAGs are very good at low temperature. They've got very low pour point, and they've got no waxing or flocculation issues. And they've also got very high flash points, so they can be used in at-risk areas. And regulatory, they're generally low toxicity and biodegradable at low molecular weight, and not too many labeling issues, really. So these are the typical areas that PAGs tend to be used in. I'll start off with compressors. So PAGs are used in hydrocarbon compressors to compress LPG and things like that. They're also used to compress ethylene for producing LDPE. I'll talk about that in more detail later. And also in refrigerant gases, they've gained a very good foothold in some of the new refrigerant gases, such as the HFOs and HFCs. In your industrial gears, they're widely used, and obviously the extreme sliding forces in worm gears, PAGs suit themselves very good to that. So they're typically used in those kind of areas in industrial gears. And in hydraulics, we can do standard hydraulic, but also water-based hydraulics as well. So in terms of the fire-resistant HFCs, that's one of the biggest areas really for us in terms of PAGs. Again, the HFCs are water-based, so obviously it helps to have a water-soluble lubricant. Again, in metalworking, we've got products for quenchants and water-miscible metalworking fluids, where the ability to make a water-soluble PAG is key, really. And then there's a whole range of other applications, so textile lubricants, where you can wash the lubricant off after you've put it through the process, and also chain lubricants, where you want to be able to wash off the lubricant and clean the chain effectively. Those are kind of areas where PAGs are very useful. So let's move on to the energy efficiency. So the worldwide energy consumption has grown dramatically since kind of the 70s. This report suggests that it's more than doubled in the years between 1971 and 2014. And it's predicted to grow in the same rate onwards as well. But most people are agreed that this kind of exponential growth of energy consumption can't continue, really. It's not good for our pocket, and it's not good for the environment either. So there's been a number of energy efficiency improvement schemes to try and reduce this energy consumption, not only to help the strain on the energy production industry, but also to avoid production of harmful greenhouse gases and CO2. So how do people achieve that energy efficiency? So significant improvements can be made by changes to the machinery itself, so the bearing design and the gearing ratios and things like that. But also, big improvements can be made by choosing the right lubricant. So if we take an example of an industrial gearbox, there's two ways where you can gain efficiencies, and those are in the load losses. So in the no load loss area, that can be influenced by the operating conditions, so the temperature, but also the internal housing design, and also aspects with the lubricant, so the viscosity of the lubricant, the density, and the immersion level and the fill level of the gearbox. In terms of load-dependent losses, these are kind of when the gearbox is in motion, so it's transmitted load, the friction of the product, and the sliding viscosity. So also, the lubricant can have a big effect on those kind of areas as well. So when we're specifying a lubricant for a gearbox, typically the thing that you focus on is the ISO value, so the viscosity at 40 degrees C. You need to be a little bit careful when you're switching between different grades because of the effect of VI. So this graph shows a comparison between a PAG 320 ISO and a PAO of the same viscosity grade. So you can see at 40 degrees they match, but at the typical application temperature of 80 degrees, the PAG is a much higher viscosity than the PAO. So this isn't a Group 1 mineral oil or something like that. This is already a decent lubricant that we're talking about here in terms of the PAO. So that gives us an advantage in terms of the PAG. We can specify a lower viscosity grade to match the viscosity at the operating condition of 80 degrees. So we can specify an ISO 220 PAG, so it matches the 80 degree viscosity, but then all the way down at the lower temperatures, so when you're starting the machinery up and you've got a cold sump and cold oil, you're gaining efficiency, so you're reducing the no-load losses in that area. Moving on to the load losses, so coefficient of friction. There's been some research by Hearn, who took 3 different standard types of industrial lubricant and compared them directly on an SZG test to see what the power loss comparison is. So what he found was basically the friction coefficient was consistently lower with the PAG lubricant, and compared to the mineral oil, there was a 20% reduction in power loss, so that's a 20% efficiency just moving from a mineral oil to a PAG in the load losses. So moving on to high performance and longer drain intervals. So PAG-based lubricants offer higher performance, as I mentioned. And there's different areas where this creates even more advantages. So in terms of hydrocarbon gases, this creates a great advantage. In having a very polar product with a high oxygen to carbon ratio, the solubility of the PAG is much lower in hydrocarbons. So that helps with oil separation of the gases. And it also gives higher chemical resistance, and that allows you to run for longer without having to shut down and change over the oil. So one of the big areas that PAGs are involved in is LDPE production. So the PAG is used as a lubricant to compress ethylene gas, and then that goes through a tubular reactor to produce LDPE. So comparing the 2 basic grades of lubricants that you can use, so a white oil PIB type lubricant, you're looking at a consumption of over 2 litres of oil per tonne of LDPE. These compressors run at massively high temperatures, so it tends to be kind of a once-through system, so that's the reason why you're getting quite a high throughput of lubricant in this system. And then looking at the packing life, so 10,000 hours is a typical area for white oil PIB. So looking at our fully formulated CL1400 PAG grade lubricant, the consumption is much lower, and the packing life is considerably higher. So you not only get all of those efficiencies from the lower friction and the no load losses, but you also get longer drain intervals. So that means you're not shutting down your LDPE plant so often, and you get higher production and throughput by using a PAG rather than a traditional base oil. So another area where PAGs have been used quite widely is in wind turbines. So SL320 is one of our fully formulated products. That's been used in wind turbines in the Horns Rev facility, which is just off the coast of the UK. We gained excellent results in micropitting and scuffing performance, and the highest result was obtained on the FAG full step. And so there's some details about the turbine gearbox. It's a 1 megawatt system. And we did a trial initially. So the trial lasted 5.5 years, and throughout the oil was regularly checked. And we saw no change in viscosity. The iron levels were fairly consistent, so that resulted in no wear. And the EP additive package was still fairly high at the end of the trial, so that gave rise to low losses of the additive package. They also did endoscopic inspection of the gearbox to check the micropitting of the gears and the teeth, and to check the general quality of the gearbox while the trial was running. And as you can see from the pictures, it looks almost as new. There's no issues there. There's no sludge, no varnish, no discoloration of the lubricant. And then after the trial was complete, we took the oil out of the gearbox and we ran some more tests, so some wear tests and some micropitting tests, scuff performance tests as well. And in all of these, the 5-year-old oil performed almost as well as the fresh oil. So from this, you can take that 5 years is not a long time really, and we could have run for an awful lot longer without changing the oil in what is quite a demanding application. Okay, the impact from new environmental regulations. So generally speaking, industry switches from mineral oil to synthetic lubes when they're looking for a gain in performance or efficiency, as I was saying before. So that case is kind of gradual, and it's kind of organic in its growth, and it's kind of picking up pace as more focus is made on the gains that you can be had by switching from mineral oil to synthetics. But there's a bigger sea change kind of thing where new regulations are brought in which can't be fulfilled by mineral oils, so there's a big step over to synthetics at that point. So I'll run through a few examples of where that's happened and how we've been involved. So the first example is with fire-resistant hydraulic fluids, which I've mentioned before. So in the 50s, there were a number of big coal fires where they were using mineral oil-based hydraulic fluids in coal mines. And then that pushed for new safety regulations. And almost overnight, all of these hydraulic systems were replaced with HFC-type hydraulic systems. So you've got a PAG, which offers the thickening efficiency and the lubrication to the system, and then some glycol and water to knock it down to 46 ISO typically. This is one of the biggest areas that we sell into. It's a high viscosity, water-soluble PAG, and yeah, the performance of it is outstanding, really. Moving forward in time, so the US EPA recently issued some guidance for discharges from vessels. So the VGP and the SVGP have been introduced, and they're still making changes now. And they require the use of EAL, so environmentally acceptable lubricant, for any oil-to-water interface. So any chance where there's going to be discharge of oil into the water, they require for that lubricant to be a EAL. So you may ask, the US is a long way away, and what's that got to do with us in Brazil? But obviously these big container ships, they go to multiple destinations, so you need to make sure that your vessel is accepted by all of the ports worldwide. So there is some rationalization of this and some alignment of all the different countries' regulations, but at the end of the day, you need to be able to send these ships wherever they need to go. So you need to almost meet the most strict regulations that there are. There's also some thought that these lubricants might extend to above deck lubricants as well. Obviously, the leakage into water is less of an issue, but obviously as these laws get more stringent, they start looking at the next step, really. So what do oil-to-sea interface lubricants involve? So it's anywhere where it's underneath the waterline, so stern tubes, stabilizers, rudders, thrusters, that kind of thing. And the EPA estimate that around 24,000 vessels will be affected by this. And the volume of lubricants affected by these VGP regulations is easily in the millions of litres. So this is a big area for PAGs, and one that we're looking to expand in. So a stern tube lubricant runs at an overpressure to ensure that no seawater gets into the stern. So they estimate that leaks from there range from between 1 and 7 litres a day. So if you think about all these massive container ships, 24,000 of them, that's a hell of a lot of oil, which is potentially leaking into the waterway. So you want to ensure that that oil is not polluting the environment. So what is an EAL? So an EAL can be defined in 2 different ways. It can either meet one of the existing regulations. They tend to be drawn up in Europe, different countries in Europe, and those are all the ones there. So OSPAR, Blue Angel, Eco-Label, etc. Or you can self-regulate yourself by doing some testing to ensure that it's not harmful for the waterways. So it needs to be biodegradable, it needs to be minimally toxic, and it also needs to be non-bioaccumulative. So the traditional technology for this kind of area has always been esters, and as Eduardo was saying in his previous presentation, esters have got some issues with hydrolytic stability. So there's not only a push from us PAG producers to use PAGs instead, but there's also a draw and a pull from the marine operators and the end users to stop using esters because of the issues with hydrolytic stability and corrosion from the increase in TAM. So in terms of a PAG, not all PAGs meet the EAL guidelines, but some do. So they are readily biodegradable at low molecular weights, minimally toxic as well, and they're non-bioaccumulative. And the one advantage with PAGs, which esters don't have, is that they're denser than water and they're also water soluble, so they don't leave a sheen on the surface. So they're a lot more acceptable in terms of a lubricant. You don't want a big oil slick trailing behind your boat. It doesn't look great, really. So there's a big advantage with PAGs there. They're a lot more acceptable. Moving on to refrigeration. So you'll all remember back in the 1930s, some of us are old enough to remember that, I'm not, but okay. CFCs were introduced, and the scientist called Thomas Midgley famously inhaled some freon gas and blew out a candle to prove that it wasn't toxic to humans. Sadly, he didn't think about the ozone when he was doing this, and they were later proved to be massively ozone depleting, and global warming potential was very high as well. So over the decades, we've looked at different alternatives to CFCs, and we've initially moved to low ozone depleting potential ones, but those had a high GWP, global warming potential. And it's only really in relatively recent years that we've started looking at low ODP and low GWP products. Now we're typically looking at CO2, ammonia, and hydrocarbons as kind of zero ozone and global warming depleting potential. So all of these changes have a knock-on effect for the oil that you use. So the oils are used in the compressor. So there's a circular loop, and you need to be able to separate the oil from the gas as you go through the different phases of the compressor. There's some miscibility challenges because you need the oil to be partially miscible with the gas. Also in the oil return, when you're separating them, it's a lot more tricky as well. And some of these newer gases are a lot more sensitive to water and temperature and They're slightly harsher environments for the lubricant as well, so you need the lubricant to be more chemically resistant. And more and more of them are looking at extended oil drain intervals or a fill for life system where you can just fill it at the OEM and forget about it. So how does this all affect which oils you use? So back in the 1930s, we were using mineral oils with CFCs without any issue. And then slowly over time, as these refrigerant gases have changed, we've moved on to different technologies. So PAGs really got involved in the 1990s with the HFCs and PFCs. That was a typical standard PAG, a BPAG. And now where we're looking at the more specialty gases, we started looking into double end capped PAGs, which have a very low water uptake and very good chemical stability. So that's the area that we're in now, and those are products that we make at Hive in the UK. We make fully formulated products, but also base fluids as well. So the technology is kind of split into two different areas now. This is where we stand at the moment. In terms of mobile refrigerant gases, so this is air conditioning for cars and things like that, anything that moves. They're slowly phasing out R134A, which was where we used the single end cap PAG, the BPAG, and then moving on to R1234YF and CO2. So these are areas where you definitely need a double end cap PAG. In terms of stationary, so those are air conditioning for houses and refrigeration units. Most of them are the same, so 1234YF is the same, ZE is the same, and CO2 is still used, but they've also got some other options which don't necessarily need PAGs. So yeah, the two technologies are kind of diverging a little bit. So in summary, PAGs are an established technology in the synthetic lubricant market. We've been around for more than 50 years. And PAG technology is gaining an even more bigger foothold as these trends and these regulations come to play. Energy efficiency is a big issue for us now, so PAGs can definitely give some opportunities there. And the stability and the load-bearing capacity of these products is really helping customers solve problems. Okay, so I'm open to some questions. As I said, I'll be at the IMCD stand as well, so if you want to talk to me after the show, then I'm happy to be there. I'll be there until around tomorrow afternoon. Okay, thank you.